So
First order.
if I put that, it means increasing, decreasing, flat, concave down, concave up. Okay? It's not union and intersection. Let's see. You look at that function and tell me if it is concave up, concave down, inverse is concave up. What?
Because the first term is positive.
I can't even see the first one.
I see where you're going.
So this equation is simply or it simply corresponds to the graph of a parabola. So this is simply a parabola if you graph it using the calculator, and it is opened up, so it will have a minimum.
I think we don't use the calculator first. You can see the coefficient next to that.
So f prime of x, what rule should we use to find the derivative? Chain rule. So 2 moves to the front, x minus 1, derivative of x minus 1 is 1. What is the derivative of 16? 0. 2 times 2, 4, multiplied by x minus 1.
4x minus 1.
We have to set that equal to 0. And solve for a value, and that value would be the critical value. Well, divide by 4 on both sides. X minus 1 would equal 0, which would mean x is 1. Let me go ahead and find the second derivative. Also, what is the second derivative?
Second derivative is 4.
4. Now, I wrote a note that if you plug in the critical value in the second derivative, and if it is bigger than 0, then it will correspond to a minimum. The critical value will correspond to a minimum. Well, what is the critical value? It's 1. But no matter what you put in here, it is always going to be bigger than 0. Do you agree? So this simply tells me that the critical value corresponds to a minimum, because this doesn't depend on x, so no matter what value I plug in, it'll always be bigger than 0. So, first derivative test. Critical value is 1. Pick an easy number less than 1. 0. So f prime of 0 would be 4 times 0 minus 1, negative 4. Is that less than 0? In other words, negative? Yes. So decrease.
Wait, so where exactly did you get? Oh, no, I'm sorry. I thought that was the second derivative for a second.
Plug in the test point to the right of the critical value. Pick an easy one. 2. Positive 4, bigger than 0, so increasing. Good. So I can write the intervals where the function is increasing and increasing or decreasing. So the function is increasing for all values of x in of course, I shouldn't put in parentheses right next to negative infinity. So that is my conclusion. But as you write it down, let me ask you this question. Did I make a mistake? What?
Because you said that the red side's increasing.
Okay, I have it backwards, thank you, Kitten. Well, that killed my motor entirely. But now that I fixed it, did I still make a mistake?
We haven't done the second derivative.
Is it the one? Is it the one? Because you said that
Is it the one? What's wrong with the one?
the f of one shouldn't be 0, so it can't be like the brackets. It should be
Very good.
parentheses.
So I can never put a bracket, right? Because one is a critical value, and we know that's where the function turns. The point where a function turns is neither increasing nor decreasing. By all means, at a very small interval, it is flat, right? So never include the values. Or the value in this case. So no brackets, just parentheses. Are we clear? Sure, I can do the second derivative test, but I don't have a point of inflection, right? So I can just put the conclusions that I have thus far to come up with the nature of the curve.
So would it be both are concave then?
No, give me a second, no points of inflection, one critical value that corresponds to a minimum. That simply tells me what the minimum that I have is an absolute minimum, and the function is concave up for all values of x. Yes?
You said there's no point of inflection? How do you know there's no point?
Can you solve for this?
Oh,
4 is not equal to 0.
That's what I was about to ask. Is that in any case, if there's a constant for this second derivative, you know that whatever your minimum is absolute, or if it's a max?
Probably, okay. On an interval.
Okay.
On an interval. What was your question? Did you have-
So what exactly we listed as concave or concave down, or we just listed as nothing?
Concave up.
Concave up.
So
For both possible x's.
it's concave up for all. For all real numbers, and whatever value that we found. There is an absolute minimum. So this is a problem which I pick so that you understand the process. But do you need calculus to come to this conclusion? Hypothetically, let's say you don't have a calculator. But still, do you need calculus to come to this conclusion? No. Algebra is good enough, right?
I have a question on, you said there's no point of inflection?
Yeah.
Isn't a point of inflection where it just turns?
Yeah.
Also, there's only, so since it's not turning into anything else, there'd be no point of inflection.
Yeah.
Okay.
You get turns as in concave up to concave down, not increasing to decreasing. So I am going to do both the first and second derivative test, but when I do it at the end, I'll show you as to one of the tests wasn't even needed. Going to find the first derivative, which is 4x cubed minus 4x. Want to set that equal to 0. Which would mean 4x cubed minus 4x equals 0. Most common mistake. You would move that 4x to the other side, get rid of the 4, get rid of the x's, and then solve for x, and you get x is equal to plus or minus 1. Incorrect. Factor it out, so you have 4 times x squared minus 1 equals 0. Divide by 4. X times x squared minus 1 equals 0. 2 factors, set each of them equal to 0. So first factor equal to 0. Second factor equal to 0. If x squared is 1, x is plus or minus 1. Right? So there are 3 critical values, but we want to make sure if they all correspond to a change in direction. So unfortunately, things are tricky here. This is where table set comes into play. Have the original function typed in, plug in an easy number between 0 and 1. What is an easy number? 1/2. If you plug in 1/2, what do you get? What's the number? Negative number. Has to be a negative number. Yeah. So decreasing. If you plug in negative
So
1/2.
you list 3 critical values, not including, did you list at the very least, x squared as being equal to 1 being a critical value? As well
If
as-
x squared is 1, x is plus or minus 1, 2 critical values.
Oh, no, okay, I thought you were listing it as like 3 separate things.
There, this and this.
Yeah, I just wanted to.
If you plug it in the calculator, it has to be positive. Yes. So, and pick an easy number, less than negative 1.
Negative 1.5.
Easy number.
-2.
Negative 6. I told you, it's ridiculous to pick something like negative 1.792. Negative 2. And that has to be less than 0 if you plug it to the calculator. And on the other side, if you plug in positive 2, use your calculator, that will be bigger than 0. Good. So the first thing that you have to do in a problem like this, take the original function, put it in the calculator, have table set ready, have the graph part ready. Good. So if you graph it, the function should look like that. Does it correlate with what I have here? So if I simply trace it out, down, up, down, up, doubling. Correct form. So where is the function decreasing? The function is decreasing on this interval and that interval. So I want to combine the intervals, so how do I combine? What should I use? Union. the function is increasing on that interval minus 1 to 0 and 1 to infinity. So increasing here, increasing there, negative 1 to 0, union 1 to infinity. Decreasing here, decreasing there. So negative infinity to negative 1, decreasing union 0 to 1. Yes.
So once you solve for your critical value, you would pick a value between the 2 points. Find out if it's increasing or decreasing.
Yes. And where should you plug it in?
You should plug it into the second derivative.
Here. We're doing the first derivative.
Yeah. Oh, I'm sorry, I thought we were doing the second derivative.
No.
First derivative. You plug it in the first derivative. Onto the second derivative.
Yeah, I thought that was what you're calling it.
If I take the second derivative, what is the second derivative of 12x cubed minus 4x?
It would be.
I'm sorry,
It-
4x cubed minus.
it's full minus 4, right?
My brain is going one step ahead of it. So we want to set that equal to 0. So 12x squared would equal to positive 4. X squared would be equal to 4 divided by 12, or 1 over 3. 4 over 12 is 1 over 3. X squared is 1 over 3, which means x is plus or minus 1 over root 3. It is the same as saying root 3 over 3. They're one and the same.
Effectively, the reason why we didn't use the same process as the factoring thing that we did in the first derivative is because we didn't have that possibility. You gotta do it.
Mhm.
Because inside of the first derivative, we could then take out the x.
Yes. That is correct. Okay, now you have to pick an easy number between negative 1 over root 3 and positive 1 over root 3. That is about negative 0.3 and positive 0.3. What number would you pick? What? 0. Where should we plug that in? Second derivative. So if I plug it in the second derivative, I have 12 times 0 squared, which is 0, minus 4, which is negative 4. Is that less than 0? So over here, is the function concave down or up? Does that agree with that part? Yes? So I know I did the first derivative test, things down here, things down there. And with the second derivative test, these are the points of inflection. So just by using logic, the function has to look like that on either end. Correct.
So you could
Which
use,
is why I said in the beginning, you don't have to do both tests. If you do one of them, you can simply deduce from that. So in what intervals is the function concave up? Up.
Negative infinity and negative 1 over square root of 3, and then union square 1 over square root of 3 is infinity.
So in web design, when you do the homework, this is what they would want. They want the answer in terms of an interval. And where is it concave down? It is down negative 1 over square root of 3 and 1 over square root of 3. when you review this, review your notes. That is union, but that is just my shorthand notation for looking up and looking down.
Put the arrows on
Don't
it.
get, what's,
If you
Make
put
the
the
arrows.
arrows on the ends, then you'll know. There you go.
it looks like a smiley face in the front. Okay, good places to.
Oh.
If you have questions, talk to me, if not, I'll leave it.